Okay, it is 40 minutes after, which means I'm allowed to start. Hi, I'm Tanya. Thank you so much for coming. This talk is, how do I explain this? So I was applying to Black Hat because I am a masochist. And every year I apply and then they reject me. And my boss at the time was like, I need you to apply. And they're like, apply with something really weird and maybe they'll take it. They didn't. But I was reading all these books about behavioral economics and the science behind why we do the things we do. And I've always had trouble understanding why people make certain decisions. I've always been very curious, like, why do they do that? Why did this happen? Because I don't understand why people choose the things they choose. And so behavioral economics helps explain a lot of those decisions. And it also talks about interventions, so things we can do to help guide people to the decision we think is best for them, which is different than social engineering, which is pressuring, manipulating, and tricking people into decisions. For instance, your doctor tries to convince you not to smoke, for instance, right? They don't try to trick you into it. They try to show you that that is the best choice for you. Is my hair?
I think it's buffing
the necklace. Okay, so no necklaces. Understood. That's okay. I don't need it. I'll be okay. Better, thank you. And so I was reading all these books and I realized I was doing some of those things as part of the AppSec program. So I started doing more of them and I got better results. And then I was like, well, what if I took 10 bad developer behaviors? So things that are really common, that I have definitely done most of, that result in insecure code, usually. And then what if I try to figure out how I could address those with behavioral economic interventions? And then I was like, oh, this is super interesting. And then I'm like, maybe I could just apply with this super weird talk. And then, obviously, they rejected me. It's been 8 years in a row, so this year might be number 9. Let's see. But OWASP took it, and I've been doing it everywhere since then and writing a blog series on it. And I've met a lot of very interesting people as a result, which has been really great. So yeah, this is the psychology of bad code. So what are we going to talk about? How to threat model the humans and what we do. Behavioral economics, like I said, it's the science of why we make the decisions we do. And then how we could use both to try to create better code. Oh, is this the most burned out you've ever been? No, just so far. Don't worry, it gets better. How many of us here are software developers? Awesome. How many of us work in some sort of cyber-ish infosec-y thing? Okay, cool. Thank you, all of you, for coming. Okay, so who am I? So I'm Tanya Janca. This is the mandatory About Me slide where we brush our hair in our photo before you see us, and we try to convince you we're competent enough to give our own talk. So I have written 2 books. I give secure coding training. I have worked in tech. It's 29 years now. I founded some companies and communities and open source projects. I'm an advisor for some startups. I write for Stack Overflow. Honestly, I write for a lot of people. I'm very promiscuous with the writing. I helped write the new OWASP Top 10. I'm a board member for the Forte group, and hopefully, above all, you're like, she seems fairly tolerable. I will sit through this until they give me more snacks and coffee. All right. So now that you know me very well, this is our agenda. I like telling you what I'm going to tell you. Then I tell you, then at the end I remind you what I told you. I'm one of those speakers. I like to tell you where we're at. This is where you could go get the slides right away if you're like, I just need to know the answer now. I'm gonna give you some QR codes throughout the whole thing. And I know how some people are like, oh, you shouldn't click on random QR codes because then it's insecure. No one would ever hire me again if I gave you a malicious QR code during one of my presentations. So I feel like it's okay, it's okay. Okay, so threat modeling the human element. So I asked the AI to make some sort of thing to represent this, and I don't like it at all. But essentially, for a long time, the information security field, like the cyber nerds, we've been saying, oh, developers are bad and everything's all their fault. But I was a developer a lot longer than I've worked in cybersecurity, and I don't agree. I think that we have set up systems that make it really difficult for them to always be perfect. We expect them to memorize 12 trillion things. We expect them to go extremely quickly and learn tons of things on their own with no help. We give them tools that kind of suck. And then every time they make a mistake, we tell them they're terrible. And you know what? It turns out it's not working very well. Has anyone seen this work well? So I want to write a talk about how instead we could set up software developers for more success. And so I don't think that AppSec is failing because we don't know what secure code looks like. Yeah, I think AppSec's failing. I think that we are not winning. I think that it's really hard to have super secure apps, especially legacy apps. I think that lots of us have tons of things in the backlog that we have no time allotted to fix. I think that things are changing very quickly all the time, and none of us get almost any training. I think that the tool set just tells us how wrong we are later, very late in the SDLC. I don't think we're winning right now. But I do think a lot of it is because how people behave. When we put them under pressure, we give them great complexity, and then we give them perverse incentives, like, we take security seriously, but we're only going to give you a raise if you get this feature out by Friday. So behavioral economics, like I was saying, it applies psychology insights to how we make decisions. And it explains why people don't save enough money for retirement, even though we totally know we should. Why, if we put a snack at eye level, we'll eat that snack more often. And why, if someone nags us, we are so not doing that thing. But if we have a nudge, we probably will. And so it really helped me anyway understand like why people do the things they do. I'm still working on that whole why people do, but it's opened my eyes for a lot of things, and that's cool. And so lastly, my theory is that if we apply these behavioral economic solutions or interventions, as they call them, to our security programs, we'll just get better outcomes. So if we take, like I said, the bad known behaviors like not doing any documentation or skipping tests so we can get to prod, et cetera, and then we apply these interventions, we'll get more of what we want. But let's look at it. I'll tell you more. Okay, so patterns of insecure behavior. So I'm gonna show you the 10 things and the heuristics and just say them briefly, but then we're gonna dive into each one, so you do not need to memorize this. But I like to put it all on one slide because you need to hear something 3 times that is complex and new and abstract to learn it. I do not expect you to learn all 10, but I'm hoping maybe you take away 1 or 2. And because I like taking pictures of things and having summaries, so I made one for you. So on the left, we have the bad behavior. And by bad behavior, I mean, like, we know we should do documentation, and we don't do it for reasons, and I'm gonna explain the reasons. I do not mean that I am blaming developers and saying they're bad. I'm saying this is stuff we do that we know we probably shouldn't do or we should do, but we're not doing it for a good reason. And then cognitive biases. So a bias is kind of a preconceived notion of why we would do a thing, or a prejudgment, and a heuristic is more about how our brain automatically does this habit. So if you've ever moved, like to a new neighborhood, and then you go to work for the first time, and then you drive or walk home, and you end up at your old apartment, and you're like, how did this happen? It's because of the heuristic in your brain, the automation is, oh, I do this now. Okay, so the first one is vibe coding, and just trusting the output from the AI. And this is automation bias and cognitive offloading, which we're gonna discuss. The next one is just copying and pasting from forums, but we all know that actually means Stack Overflow and why we do that. Rushing due to tight deadlines. And this is because we want money and not to get fired. Avoiding documentation. So there's a lot of reasons for this, but there's an interesting tragedy of the commons is pretty interesting. Skipping error handling or skipping tests and just like going straight to prod. Obsession with shiny new tech. I mean, we're technologists, so of course we like new tech, right? Committing untested code. So just like skipping tests altogether. Over-engineering things. So if anyone has ever seen code where it was like 5 or 6 or 10 lines of code, and then someone turned it into 1 line that no one can read or ever debug again, and they're like, I'm so cool, and I'm like, ooh, about that. Number 9, ignoring compiler warnings. oh, it compiles, therefore it's fine. I don't care if I have 37,000 warnings. I'm going to be okay. And then the last one is fake code review. So you're supposed to review it, and you don't really, and you just commit it. Did anyone see, I think it was last month, where Anthropic released a study where they had timed how long people were reviewing code changes that were brought from Claude, like there were PRs from Claude, and it was less than 1 second for a human to review it, which means no one's reviewing. It was something like 96% of the reviews were less than 1 second. So the human in the loop thing, it's not really happening at a lot of places, it turns out. So, okay, so if you wanted to take a picture of this, you could do, it's in the slides at the end as well. Okay, so more. So why insecure code, or why insecure behavior matters? I'm gonna go quickly over this part because there's 5 different tracks, and there's Hallway Con, and there's many other things to do in Toronto. And if you really gave no cares about security whatsoever, you would be in any one of those other spots instead of this spot. But basically, technical controls can't outscale humans. Software developers are like water. They can literally just go around anything. We go through the hoops that the security team does because there's policy and because we're supposed to, but not because we have to, no matter what they say. Those things are reactive. But if we change behavior, that's proactive, and that's what we want. Another reason is these behaviors become systemic rather than, it's not like one dev is doing a bad thing at a company of 400 people. It's that this is the way we do it here. We're all doing it that way. Especially if your team lead does it, all of you are gonna do it or not do it, right? It becomes part of the team culture, and like, this is how we do this here. 3, if we leave these behaviors unchecked, they'll scale across the entire organization, right? Bad habits can compound and turn into bigger bad habits. Like one small shortcut today can become something huge later. And then there's lots of other reasons. Like it undermines the effectiveness of our security investments. It helps us it makes it okay to bypass security controls, et cetera, et cetera, et cetera. I had lots of reasons, but I feel like you know that we shouldn't do bad things on purpose. So does anyone have questions about this part? Because I usually just gloss over this part because I'm like, you're all smart. I feel like you know. We're okay to just continue to the better part? Yes, thank you. Everyone doing okay? Awesome, yeah. Okay, excellent. So now, behavioral AppSec. So nudges that work. So we can fix bad habits. And by bad habits, I mean in our personal life, in our professional life. If we have like little ones in our lives, or other people we're trying to influence, like staff, we can use behavioral interventions to try to help change things. And by that, I mean changing the environment and the processes, and sometimes the tooling around the system to help them make the choice that we want them to make, right? So like if we put apples and pears and bananas on the counter every day, and we make it so you have to stand on a step and then open a cupboard that's really high and then reach to the very back to get a chocolate bar, we're gonna eat a lot more pears, right? Because it's just easier. Someone's like this. They're like, to hell with pears. But you'll have to intentionally decide, I don't want fruit, I'm gonna go have the chocolate, right? So I feel that there's three things overall that we can do. So in the next section, I'm gonna detail the 3 things. But basically, if we design technical nudges, so a nudge means a subtle change in how we present a choice, and we structure it so that it predictably influences people's behavior on average, but we don't restrict their options or significantly change incentives. So it's not like if you only eat pears, I'll give you $5 every time, because that would be an incentive change. This is that we structure the way things are presented so that they choose the thing we want them to choose more often. So we're not pressuring them, we're not intimidating them, we're not tricking them. We're just trying to show them the way. Does this make sense? Okay. And then on top of this, incentive shifts. right? So an example of this would be like calling out things that you like and saying good things about them. It would be us giving a raise to someone because they fixed tons of security bugs. It would be like there's lots of, I'm going to give lots of examples later, but praising the behaviors that we want. And then the third thing is intentionally doing cultural changes where you work, because that's, oh, dun dun dun, this is the beep. So they told me this was going to happen and I was supposed to tell you before it started, but they're testing a system and they're like, just make cute jokes while it's happening and it'll be over before you know it. And it was.
There is no danger to your health or safety. If this was an actual emergency, you would now see instructions for protecting yourself. For more information about emergency alerts, please visit www.
We're testing this. Okay.
System and alert of Ontario. Il n'y a pas de danger pour votre santé et votre sécurité.
They did this in British Columbia for the Amber Alert, which means like a child's gone missing. But they didn't tell us it was coming, and holy moly, did I freak out when my phone and all the phones in the house went off at the same time. And it was way louder than that. And I knew I had my sound off, and oh my gosh, I jumped out of my seat. So it was really nice they told us it was coming, and I was supposed to tell you, I'm sorry. But hopefully that was okay. Okay, so an example of this would be automatically enrolling employees in a retirement savings program and then getting them to opt out. Or in a lot of, well, not a lot, in some countries, they'll automatically opt everyone into being an organ donor, and you have to opt out. In Canada, you have to opt in. And I used to live in Ontario, and I opted in, and when I moved to BC, I did not know they opted me out. And I didn't know for a few years, and then I opted myself back in. What if I died and all my organs went to waste, right? And so if we automatically opted everyone in, most people would be organ donors. And if you walk around in Canada and ask people if they're an organ donor, a very large percentage will say yes, but it's actually only like 12%. It's very, very low because people think they've opted in and they don't know that at some point either they never did or they were opted out and they're unaware. So if you are Canadian, you should check that out if you care. Okay, so in this section, I want to give you 3 concrete things you can do, period, even if you have no idea what bad things developers are doing that you don't want them to do anymore. So, because sometimes people are like, well, I don't know if they're not doing documentation, or I don't know if they're doing this or that, but I want to help. So I'm just going to give you 3 things to start. Also, building systems that support secure employee behavior, right? Because we want everyone to have better security behavior. So if you work in different areas, like if you're a dev manager, or you're a team lead, or you're a sysadmin, or whatever, like these can still work for you. So the first thing is setting secure defaults instead of assuming people will have secure intentions. So most employees, including developers, intend to make secure decisions at work, like they intend to write secure code. But intentions mean we have to do constant effort, right? It means memory, it means willpower, it means taking the time to intentionally do this thing. But defaults are automatic, right? So when the secure path is the default path, you don't need to remember to make a decision or exert any sort of willpower. And it means you'd have to actively decide to undo that work in order to make an insecure decision. And so usually there's a business requirement or some sort of reason that you're doing it, and hopefully you're documenting it and telling someone, right? But then you'll make a better choice. So for instance, I used to have to walk to work. So I defaulted to exercise. I could have taken 2 buses or I could walk. So I walked, so which meant I got lots of exercise all the time, right? Another example would be, we're supposed to use parameterized queries. We're not supposed to just concatenate a bunch of user input together, build a query, send it to the database to be executed. We're not supposed to do that. But if we use an ORM, like an object relational mapping framework over top of our database and to access our database, and that's all it allows is parameterized queries, then we're not going to do crappy inline SQL, right? Because we can't, or we'd have to exert quite a bit of effort to do it. And so when we make the the default, the secure way, the easiest way is the secure way. We get that more often. So this would be sort of the first thing that I would want us to do, is set as many secure defaults as we can. And I'm going to give some examples. And then the next one is adding it to your secure SDLC. So ideally, we are building software with a system development lifecycle, right? We are gathering requirements, designing, coding, testing, and releasing, and not just flying by the seat of our pants, hopefully. And so I'm going to talk about how to embed these so I want us to embed it into the system development lifecycle, but also the tooling we choose. And I want to talk about like doing training in this brand new, different way. So the first thing is, so if we're, just a second, so the SDLC, my favorite thing. I talk about this a lot. So if we can include in part of the SDLC, like when they choose frameworks or languages that we help the security team gives guidance, or the security team is available and there's an obvious process to help you choose, like make safe choices there, that's a huge step, right? If we add, who here has done threat modeling before? Okay, so a couple hands. I dream of the day every hand goes up. Threat modeling is a discussion about your design where you try to identify bad things that could happen, and then you add mitigations so those bad things don't happen. Basically a secure design review, but with less paperwork and more discussion. Adding IDE tooling that flag risky behaviors or functions. Having a template in your pull request that comes up that tells you what to review. Like when you're looking over the code, here's security things I need you to look at. Another thing would be, so this is the main thing, is for every phase of the SDLC, if we could have a security activity. So like if we're gonna gather requirements, I assure you, I have some security requirements I'd really like you to add. If you're gonna do a design, I'd love to look over the design with you and talk about it or whiteboard it or do a threat model or whatever you will tolerate. Right? Each step, if there's some sort of security activity, you will get way better results. For tooling, so who here has a pre-commit hook that runs that scans for secrets or something else when they check their code in? Okay, so one day, I want all hands to go up. This is a thing that you could set up. So when your code gets checked in, like as it's being checked in, it just scans to see if there's anything that looks like a password or a hash or a secret of some kind. And it's like, whoa, Nelly, let's rethink this. Who here has any sort of security IDE plugin? No? Okay. Yeah, I've found that a lot of the IDE plugins like slow things down a lot, and they're not perfect yet. We're still working on it. Okay, how about CI/CD checks that look for security issues and might block? Okay, I'm seeing some hands. Oh, more hands, yes, okay. So that's later in the system development lifecycle, but way better than never. A dashboard that shows security debt. I've only met like 3 people that do this. Is anyone doing that? Yeah, I'm seeing 2 hands, all right. Do we share that with the developers? Okay, 1 nod, yes. Because I want the developers to see it too. Okay, so the last,
In that context, what do you mean by security?
Yeah, oh, this is awesome. So some of it would be security bugs. So we know that there's a medium and high vulnerability in this app that we need to fix. Some of it would be, so let's say our old apps, we wrote our own authentication and authorization and session management, but in new ones, we're using like Okta or Incognito or whatever you want to use. And we know we need to update them eventually. To me, that would be security debt. It's work we know that we need to do that's definitely going to make us more secure, but it's not on the schedule. That was a great question. Thank you. Okay, so training. So I think we should not teach what to do, I think we should teach like why this would be easier, or why your code's gonna be way better and tougher and more rugged. I think instead of having one training for 1 day per year, what if instead we had something every month, like a community of practice? Or we had like a subscription to some sort of service, or we had books, or whatever it is. But once a year for me is not enough to keep up to date. Teaching patterns that people can recognize in their own behavior so that they can do better, rather than memorize the OWASP top 10. And I realize I helped write the new, who knows what the OWASP top 10 is? Okay, so OWASP is this international nonprofit of nerds like me that are obsessed with the security of software, and we have over 100 open source projects. We have international conferences, we have over 300 chapters around the world, and we have a lot of drama. And the thing that we are most well known for is called the top 10, which I helped write this year, or last year, and it is basically the top 10 risks to software. It's supposed to be to web apps, but we just cover everything now because YOLO. And it's the thing that people know us the most for. Getting you to memorize that, turns out that's not working. If we can make things social, right? So if you could do a security champions program or pair programming or anything else to like make learning more fun, people will do better. We could make it more memorable, and by that I mean have some sort of reminders. So I do a lot of cheat sheets. If you could like talk about it in team meetings or whatever it is that you could do to remind people but not annoy them. If you can make it fun. So if you have some sort of like community events, or you have challenges, or I'm not really huge into gamification. I personally don't like enjoy that very much, but a lot of people do like leadership boards and stuff like that. Like whatever you can do to make it more fun, you'll get better results. So instead of thinking secure coding training, what we want to think is behavioral and cultural change, right? Because that's what we want. Right? We want people to act differently. I don't want them to memorize a bunch of functions that they shouldn't call. Like, I do want them to know that, but instead I'd rather that they call the security team and ask a question, or that when they get something out of code, they're like, oh, maybe this won't be perfect and I should review it, right? So traditionally we did the OWASP top 10, which I talked about. So talking about vulnerabilities and memorizing vulnerabilities and exploits, which I don't think helps you write better code. Doing training once a year, really long sessions, compliance focused. Who here feels that compliance and security are the same thing? What, no hands? One person's like, instead, like behavioral, like have more regular events. Like does anyone have a community of practice at work? No hands, okay. A community of practice is usually software developers that meet once a month and teach each other things. I've had really good results with that when I was a developer. Have shorter lessons, create cheat sheets or things to memorize things, review good code and bad code instead of memorizing vulnerabilities. Focus on design, like things, focus on the outcome you want, right? So change your environment. So put security information where the decision happens. If you have to search through a wiki that you don't know where the security information is, you're not gonna go find it, right? We already talked about that. Giving positive feedback for the things you wanna see. So there's not like a system you can buy that does this, I'm sorry. Like I don't know a service or a tool you can buy that does all these things. These are things I'm hoping that you'll see some of them and you like them and you'll do them. I don't like loss framing. I don't like pointing out negative things to make people do what you want. I'd prefer positive reinforcement personally. And measure the things that you actually want. So don't measure like a seat in a butt in a seat, or like someone attended 3 days of training, check mark. Instead, what we want to see is they're fixing vulnerabilities more. They're actually writing better code. We're not seeing the same mistakes. They're talking to the security team more often. Like those are the things, the actions we want to see. So measure that, which I know is harder to measure, but that's what you actually want. So these 3 things can build on each other. So secure defaults, remove friction, and people can move faster and make better choices. And then we embed these concepts into the processes that we do every day. So it becomes systemic and habit forming. And then we do behavioral types of changes and like we're changing the culture, right? And they all stack up to create an environment where secure coding, creating more secure software, is the path of least resistance. This is what we want. And so now I would like to get specific. So I call this the good part. And I thought I had a QR code here, but apparently I don't. Anyway, so I want to get into each one of the things. And so again, I'm going to give you the complete list because I'm like that and I love lists. So you might not know which habit your developers are doing. So you might need to look into this when you get back and see which one you think is the worst. Or what you could do is talk to different team leaders, talk to the rest of the people on your team, or just do these things for yourself, right? Like every little change adds up to better results. When I started my community of practice, it was just for me and my 5 devs. Then my boss liked it. So then I started having these monthly events with all of the developers. Then other areas of IT started showing up. And then before I knew it, my little government department was streaming to the rest of the Canadian government, and any developer could show up and see my monthly little nerdy thing that we were doing. It's not like we had hundreds of people show up, but every person that showed up, like, it's more value for our organization, right? And your grassroots thing can get bigger and bigger if you feed it. Okay, so number 1, vibe coding. So who here might use an AI assistant sometimes? Yeah, so, I mean, all the people that didn't raise their arms, I know our arms are very heavy, especially after lunch. They weigh a lot. It's hard. Okay, so what are the biases? Actually, let me back up. So I define vibe coding as, so it's one thing to use an AI to help you. It is another thing, vibe coding, this is how I define it, is where the AI is actually writing almost all of the code entirely. And this is my definition, so that's how I'm going to describe it. And it is doing most of the work. You are not necessarily reviewing all of the code or any of the code. This is the pattern that we're seeing quite a lot of. If you're using it to help you write code and then you're rewriting it and making every single part of it your own, that's very different, and then I'm not as concerned. So this is what I'm concerned about. So the biases here are automation bias, which is like, oh, let's automate everything away so things go faster and there's less errors, which as technologists is pretty much our job description. And then cognitive offloading is again part of what technologists do, which is whatever we can do. So some people will say, oh, it's being lazy. It's not being lazy. It's about how can we get technology to do the work for us so that we don't have to, and we can focus on the extremely interesting and novel problems. And we get everything automated that we can. So why do people do this? Like, we trust AI suggestions very easily because they appear extremely confident. The code looks very clean. It looks very professional. It looks very plausible. It doesn't look awful, or we wouldn't accept it, right? It's syntactically correct. It's very fast, and it compiles, and that's pretty sweet, right? So what could we do about it? So I like the idea of giving prompts to users that they use with the AI every single time to have it create more secure code. I have free AI secure coding prompts that I give away, which should be on the slide, obviously, but it's not, at securemyvibe.ca. Yeah, I know, it's not the best URL, but anyway, I needed something catchy, but I'll send it to you later if you want it. But basically, if we have some prompts, that will help. If we set up a RAG server, so a retrieval, augmentation, blah, blah, blah server, with good examples of like, this is how we do authentication here, this is how we do session management here, this is how we do input validation here, that will help us also like produce better code. So it goes and it references those examples first before it's learning that it did on the internet on Stack Overflow and other places. And I love Stack Overflow, but just because something's voted to the top does not mean it's safe to put in production, right? And on top of that, we should manually review the code. And I know that a lot of us are not doing that, but we are saying this is my work and submitting it. And I don't like to put my name on things that I don't recognize personally. So use a RAG with excellent examples. You can turn your secure coding guideline into prompts. That's what I did. You could have a checklist for code review for when people check in code from the AI. I have a lot more to say about this. I give talks and training about this, so if you want to talk about it after, I'd love to. I still have like 25 minutes, right? Okay, cool. Okay, so tight deadlines, taking insecure shortcuts, right? So present bias or hyperbolic discounting, which is what it's cost, it means assuming everything's fine now, so it's gonna be fine later. Nothing bad's gonna happen to me, it's gonna happen to someone else. It's gonna happen to our competitors, not to us. A lot of people think this way, and it doesn't really help us. So why? Future consequences, like a security incident, feel less real than the immediate rewards we're gonna get for shipping on time. So what do? So we could have time-based nudges. We could have, my favorite is secure by default templates. So if we have secure default set up all the time, if we have templates that developers use of like a secure coding library, so there's code samples that we just reuse that we know are good, or maybe we have a DLL that we include, and it does like different security things for us. There's lots of things that we could do to reuse known good code so that we could go faster. And that would help with this. Those are two potential things. Okay, so number 3, copying from online forums, and it says or AI, but without context. So this is authority bias, and then also availability heuristic. So authority bias is basically, how do I word this? It's voted to the top on Stack Overflow, so obviously it's right. Stack Overflow is the one we all copy from. It's the best one, so I know it's safe. Then availability heuristic is basically I see it over and over and over again, and therefore it must be correct. When I was researching my book, I would find the same thing stated over and over again that was wrong. And I don't know if you know, but oh my gosh, people plagiarize each other's blogs all the time. And they'll even plagiarize stuff that's completely wrong over and over. So I would see the same thing 10 times that was wrong. And I'm like, should I send letters? Like, I don't know. Do I send letters and complain about plagiarism, or do I send letters and tell them their plagiarism's incorrect? Anyway, so why do people do this? Because we assume if it's upvoted, okay, I really didn't move that much. Can we try again? My hair doesn't seem that damaging. I'll just, okay. I'll try not to be too movie. Okay, thank you. Okay, so if it's upvoted, we assume it's trustworthy. The most available solution, the solution we see over and over, seems right. So how can we fix this? So who here uses a linter? Okay, awesome, way more than 0, yes. Who here uses a static analysis tool? Okay, all right, so these things can help with this. So they can go over and be like, you know what, this is bad, you should not do this. This is a thing you can do to just check to see if you've made a grave error. So checking that, and then also we want to do code review in general, but I mean, if we're looking at it and it looks right to us, we just reviewed it, right? And that's why we would use the linter, the stack analysis tool as a double check, like running a spell checker. So obsession with shiny new tech. So last night I just released a blog post on this. So basically, the biases are novelty bias and FOMO, fear of missing out. So what does that mean? New is exciting, right? Engineers, sometimes we tie status to tech fluency. So it's like, of course, I know OpenClaw that came out like last week, and then this replaced it, and I know that too, and that replaced that, and I know that too, right? But security rarely keeps up with all of this. We are always way behind the developers. I know we're trying, security folks, I'm not blaming you. So they move pretty, developers move fast. Okay, so how do we fix this? So if we can add a security review for tech adoption processes, that would help. Ideally, you would have a sandbox area where developers can play with whatever they want, and it is air-gapped between production, so nothing escapes, like Mythos. And then they play with it for a while, and then they throw away like half or 3/4 of it as not very good, and they only ask the security team to assess things that they're like, okay, this is really good, I really want to keep this, I would like to put this in production, and then you talk. Avoiding documentation. Do you like this? She's like, no. Who here loves writing documentation? When I gave this talk last time, one woman put her hand up, she was like, yeah. And I'm like, I wish you were on my team. Okay, so what are the biases? Effort, discounting, and tragedy of the commons. So effort discounting is us undervaluing things that require more effort now, where we see the benefit later, right? So, you know, like if you've ever tried to explain to a kid why they need to brush their teeth, and you're like, it's so you don't get a cavity later, but if they've never had a cavity, they don't understand how much it sucks. Just the same as if you've never had a security incident, you don't understand how much it sucks and why you want to do the things so you don't have one, right? And then tragedy of the commons is when everyone shares a common resource or responsibility, individuals act in their own self-interest, they can damage that shared resource. So no one wants to maintain the documentation or refactor the messy code or whatever unless it's like on your project schedule, because it's like, oh, I'm doing this work that benefits everyone and I'm getting no credit for doing it. So that's a hard problem. Yeah, no one wants to do the unrewarded work, right? It's not incentivized often to do this. I remember starting somewhere at a place that will remain unnamed, and they're like, oh, we need you to write up a project charter and get all of these signatures. And I was like, oh, when does the project start? They're like, oh, it's already over. But the project delivery office makes us have this charter, so like go do that. So I had to go do all this stupid work for a thing that was already over. It was like, oh, it was a great introduction to how crappy it was gonna be to work there. So how can we do this? So we could gamify doc contributions, like have a leadership board or badges. We could add documentation debt to sprint reviews. Basically, like we could just recognize this work. We could do it by saying it. We could do it by adding it to performance reviews. We can do it by talking about it with the team, adding it to project schedules, making this work seen instead of invisible so that it is valued. Okay, repetitive and lazy coding handling or error handling. So this is caused by satisficing. So this is sacrificing and satisfying, or sufficing added together, which means instead of finding the best solution, we settle for the first solution that is good enough. It compiles, it's fine. We know it's not great, but we're like, that will suffice. It is fine, but it's not good, and we know that. And then the other one is optimism bias. And so we believe that bad things are less likely to happen to us than other people. That won't happen to me. It'll happen to them. Nameless them. And it turns out it's not true. So why? It worked last time, it'll work again. I'm sure it's fine. Good enough is okay compared to safe. And so what do we do about this one? We can use IDEs, and by that I mean like a static analysis IDE plugin or a linter plugin, or plugging those into our CI that flag missing error handling or flag duplicate logic, flag poor quality code. So who here has something that does code quality for them? Okay, so like I remember when I was a co-op student reviewing code from another co-op student, and my boss was like, what is happening here? And she had just rewritten the code 5 times in a row rather than writing a function. And my boss was like, please make it so it's not terrible and then show it to me tomorrow. He was very, very not impressed with our other co-op students. Yeah. Okay, committing untested code. So no one has ever done this, right? I teach secure coding now, and I'll tell people like I did every crappy thing. Like I learned to code in like 1995 or 4 or something. Like I'm old. And I got taught you should save all of your database passwords and connection strings in your code, but for dev, prod, every environment in a row so you never lose them. And that was best practice in the 90s. So you have all the people like me that still haven't retired just making a mess of everything unless we've had training or trained ourselves to do better, right? So like, Anyway, that was best practice at the time. Okay, so what is the bias here? Outcome bias. So we judge a decision by the results, not by if that was stupid or not. So for instance, imagine you wait until the very last minute to start your homework assignment. But then, one day before it's due, the prof gives everyone a 2-week extension. You're like, see, it was fine. No, that was still stupid, right? Like starting a giant project the night before was still stupid. You got lucky. But it's like, yeah, so procrastination's okay. Does that make sense? Okay. You're all doing well. This is a lot of information. Okay, so why? If it seems to work, it must be fine. It must be fine. Okay, so how do we fix this? So if we can make tests a gating requirement in the CI, or require proof that we ran our unit tests, or what other tests need to happen before we're allowed to merge our code. So if we could have some sort of check that they actually ran and passed, not just ran, but actually passed, this is something that could happen. And also, maybe talking about a situation where someone did that and then there was a big incident. I feel like if we can talk about when things go wrong more often and talk about postmortems, then everyone gets to learn the lesson instead of the team that just made that mistake. All the teams get to learn, but that's me. Okay, we have 3 more. We're doing really well. All of you are being so patient with me. Okay, so over-engineering and showing off. So this is signaling theory and status-driven behavior. So signaling theory. People, not all of us, but we tend to do things to signal something about themselves, not for our direct benefit, but because we want to show people this is who we are. So for instance, buying an extremely expensive car when you still live in your mom's basement. That could be signaling theory. And then the other one is status-driven behavior. So people making choices to gain or protect their status within a team, a community, or a company. So like a 10x engineer does this. So I'm going to do this. So they're similar, but slightly different. So one is so that you get the benefit, and the other one is so people see you that way. But both of them are equally damaging if done for the wrong reasons. So why? Complex code means smart code. It's not true. Clean or minimized code might seem undervalued. Oh, it's so easy to read, it's not that good. Apparently in the 80s, software developers thought if they make their code really, really, really impossible to read and maintain, they would never lose their jobs because no one else would be able to do it. That did not go well. Okay, so what do? So we reward simplicity in a PR. We talk about it in retros. Like if I go to review code and I can't understand anything it said, kick it back to them and be like, I'm sorry, this makes no sense. What are you trying to do here? I can't read this. I'm the senior engineer, and if I can't understand what you wrote, there's a problem. I should be able to easily be able to read your code. Okay, clever does not necessarily equal better. Okay, ignoring warnings. If you have like 400 warnings when you compile your code, there's a problem. The compiler's trying to tell you something. Okay, so bias, normalcy bias. So we assume things will keep working the way they always have, and we downplay warnings or risks. Like people are alerting us to risks, but we downplay it because we've never had a breach before. It's always compiled before. It's never, production hasn't gone down before, so it will be fine. Even though people keep warning us or the compiler keeps warning us. Yeah. Okay, and so what do? We elevate high-risk warnings. What is a high-risk warning? Right? I would say that if you have a certain number of warnings, maybe that's not acceptable, right? Like maybe it's like you're allowed to have 5 warnings or 10 warnings or whatever in the compiler, and then I'm going to need you to address some of them. Or if you've had the same warning, X number of versions of the code, I need you to take a look at it and either show me why that's a false positive or I need you to do something about it. Another thing is, like, you could talk about real-world exploits that happen because of compiler warnings. I did this at work. So security tooling will often say a security header is missing and that's a warning. And then I'll show them exploits that I can do because it's not there. And then they're like, maybe we should add it. You don't really make a lot of friends at work with exploits, though, FYI. It's true.
Sorry, you mentioned
Yeah.
my risk ones were bad. You also mentioned earlier cheat sheets.
Yeah.
So do you have
So I don't have a cheat sheet. For C and C++, I have all of those settings in my book in chapter 6, I believe. And you can get it, so you can ask, if you don't want to spend $50, you can ask your library to get it, and they'll buy it for you. I have cheat sheets for JavaScript, Vue, React, and a couple other languages, but not all of them. And mostly it focuses on don't use these functions, do use these functions, don't worry about this, do worry about that, stuff like that. Only for C and C++ do I have all of the settings for the compilers, because C is hard. I felt, what languages are you working in? Okay, let's talk after. Awesome. Cool, great questions. Thank you very much, sir. See, he's angling for the book. Do you see? Do you see, smart man? Okay.
That's where the warnings are.
That's where the warnings are. So not reviewing the code, or fake reviewing, which is a huge issue right now with AI-generated code. And so this is diffusion of responsibility and moral licensing, which are two different things. So diffusion of responsibility means when responsibility is shared by a whole bunch of people, everyone else assumes someone will do it, and then no one does it. And then moral licensing is, so you do one or two good things, and then you're like, I don't have to do that good thing. I already got my points. And I had never heard of that. Like, just because I did the dishes doesn't mean that, like, if I spill something on the counter, I don't have to wipe it up. But apparently that is extremely common. And so, like, I wrote unit tests all day, so it's fine if I skip documenting that part. Or I'm gonna skip the comments, it's fine. And so, someone else will catch it. Or I already write secure code, so I don't need to scrutinize it with tests. I'm cool. And so what can we do? So we can enforce review accountability. This is a hard one, right? So if you, like person A writes a bunch of code, person B reviews the code, later there's a giant security incident, you go talk to person A and B and be like, how'd this happen? You have to do that super carefully, because otherwise no one wants to talk to you again, right? Because if you go poop all over everyone, guess what's gonna happen? People are gonna avoid you. So when you do a postmortem, you need to be really careful about this, but a thing you can do is measure how long reviews are happening for. And if a pull request review is like under a second regularly, you might wanna go talk to that person and be like, hey, so I'm noticing, you're just clicking commit. Can we talk about that? Another thing, oh yeah, that was the second thing in that list. Okay, so, this is the QR code for if you want that list of everything we just covered, but it's also in the slides at the very end. And so now I'm gonna conclude, and we totally have 8 minutes left, and Tanya's not over time, and she's doing great, because clearly I love talking. Okay, so I'm gonna just make sure everyone got it that wanted to get it, and then we're gonna go to the next thing. I'm waving at you. And I'm letting everyone take a picture. It's great. Okay, so conclusion, because I like telling you what I'm gonna tell you. And I'm gonna give you the slides again at the very end, so don't stress out about the QR code. Okay, so conclusion. So security vulnerabilities, in my opinion, are not just technical problems. I think they're predictable patterns of human behavior. I think we are setting developers up to make a lot of these mistakes. And so if we can understand the psychology behind this decision-making, we can design systems and support people in making the choices that we want them to make. And so I would like to challenge you to think of 3 things in a new way. So the first one is, instead of secure intentions, we want to set secure defaults. Good intentions just don't scale. Willpower is finite. It's very finite. So what we want to do is set up secure defaults wherever we can. I want to think of, instead of annual security training, even though that's what I sell, so this is a really bad sales pitch, I want you to think of behavioral change and how you can regularly support this for your team. So think of regular reinforcement, community, reminders, and cultural change overall. And then lastly, I want you to, instead of blaming different people, look at system redesign. So if something bad happens, it's like, why did it happen? And it's not usually Alice or Bob's fault. It's usually some sort of system or process that we have set up that doesn't work. So we want to fix the environment instead of an individual. And so what should you do next? I would like it if you identified 3 insecure behaviors and then do something about it. That would be awesome. You have my slides, so it's easy now. Pick a secure default and implement it. Add a behavioral risk to your next threat model. So obviously we're all also going to learn threat modeling after this, and then you can add it to that. And lastly, we don't want to measure, someone spent their training budget. We want to measure that they're doing things differently, that behavior is changing the way we want it to. That's what we want to have happen, so that's what we should measure. And so I have some resources for you. So these are some books that I read that I really liked that you may enjoy. I don't have Nudge on here, Nudge. Never mind, I guess I added it. I presented this earlier, and I guess I didn't have Nudge on there, and everyone's like, what are you doing? Because that's like the book everyone reads. I really liked all of these books. I found them not only like educational, but very fun to read, but I'm a big nerd, so. I have a petition with the House of Commons right now. It is live right now for signature, and it is so we can have the first secure coding law in the world. So all government departments, agencies, crown corporations would have to write code at a certain level. Right now, there's no policy, there's no guidance, and there's zero accountability. I encourage you to call your member of parliament and ask them to vote yes on 7115. I have been working on this for years, and it closes May 26th, and then after it's going to go to vote and question period. And how many of you think your member of parliament understands what a cyber is? They do not. They need you to call them and tell them this matters to you. And I know that I am preaching. This is so important to me. I worked for the Canadian government for 13 and a half years, and I felt like I couldn't make a big difference from the inside. So ever since I left, I've been lobbying from the outside. I'm like, that's right, you losers. I'm going to quit and work for you for free now. And so please help me by signing and or calling your member of parliament or writing them. Okay, I'm going to shut up now on that. I have a newsletter, and it's free. I give away free stuff like cheat sheets. This morning it got sent, so you've missed it for this month, where I gave away AI secure coding prompts. There's also silly memes and invites to things like this. I have a new podcast. It is 5-minute lessons on secure coding, and it is free because it's a podcast. All podcasts are free, but you know what I mean. And then lastly, here's just a whole bunch of resources if you like stuff. So this is basically all I do. And so if you like this talk, this could be the beginning of a long-term relationship if you desire for it to be. And then with that, these are my presentation slides, and I would like to thank you all and ask for any questions. Thank you.